Hey, today I want to talk to you about the structure of data. And by this, I mean defining the terms structured, semi structured, and unstructured data. Going forward, my goal is to create a series of videos where I discuss more advanced topics in data management. However, before we can do that, we must first come to a common understanding of the terminology used, hence, doing videos like this. In addition, I've noticed recently a greater increase of people posting about the difficulties and complexities and how working with unstructured data is so complicated and creating sort of a mystique around it. Now, the reality is, if you understand data, understand the structure of data, working with unstructured data should be just as straightforward as in working with semi-structured and even structured data. And on that note, let's start talking about the structure of data. Okay, so before we can get into talking about the structure of data, we must first define what we mean by data. So let's define data as the observation of an event or object in space-time. Now, while this is a broad definition, and some may consider it incomplete in that it doesn't describe or define all aspects of data, and while this may be true, for the purpose of our discussion, the definition works well enough. Okay, so from this definition, you can see how easy it is to create data. A person just sitting there drinking their morning cup of coffee. Now imagine that person wearing an iWatch, and that watch has a sensor and it's monitoring your heart rate. Just the act of sitting there doing nothing but drinking your morning cup of coffee, you've created data. All right. So that's actually I'm sorry, that's a really silly example. I just wanted to show off my new coffee mug that I got for Father's Day, fluff off, and to point out that just doing our normal daily activities, we create a ton of data. Now, for that data to actually have value, we have to persist it. We have to memorialize it. And that is where our fun adventure begins. So let's talk about structured data. Now, to put this in perspective, I'm going to kind of bore you with a story. Um, Back in the mid 90s, I was working as a Unix sysadmin and Informix DBA for a client. So I would routinely go into the machine room to do your normal tasks, backups and system updates and whatnot. Well, one day I went in there and one of the teams from the mainframe group was standing around this very, very large object. Turns out to be a drum drive. Now, if you've never heard or seen a drum drive, that's okay. More than likely, the device was created before you were born. So you can look up in Google and see what a drum drive is. It's essentially storage for the mainframe. And it was really prevalent around the late 60s, early 70s. In fact, this drive was built right around, I think, 1970. It had been running continuously up through the mid 90s. So for 20 plus years, this thing has been running uninterrupted, providing storage for the mainframe. They were taking it down not because it failed, but because it became too expensive and they were cheaper. They were looking for going to cheaper storage. Now, to put this in perspective, this large device, the size of a freezer chest. If you ever seen the movies where the police come into the house and they see a stand-up refrigerator freezer, and then next to it a freezer chest, they open it up and move some of the vegetables away, and you see underneath there a frozen dead body. That's the size of this thing. It's relatively large, and it's stored a massive 250 megabytes. Now, I'm kind of saying that sarcastically, but back in the day, in the late 60s, early 70s, 250 megabytes was a lot of storage. Mid 90s, when they were deprecating it and putting it and replacing it, they were able to put that 250 megabytes onto a 5.25-inch hard drive. And if you want to get down to it, going fast forward 30 years later, we now have 2 terabytes storage. This is a 2 terabyte SSD external storage that I use for client data as when I travel. That's just to show you that over time, we have increased the density of storage and decreased the cost of storage. And we shouldn't really look at structured data from today's eyes. We should go back to the 60s and 70s where you only had 250 megabytes for storage. So what that meant is that when we wanted to store our data, we had to first be careful and choose what data we stored, but then we needed to store and be as efficient as possible with that storage. So that meant removing any and all metadata that we could and still making it easy to work with the data. So one technique that they use on the mainframe was that we stored the data using primitive data types, and we stored it in fixed width records. Now, the nice thing is that in our COBOL program, you would define you would define the file type and where it was located, and then you would have a data definition section. And what that data definition section said is, okay, here's what that block of storage looks like. So I read my record in the memory, that block of storage, we know that the first field is this number of bytes wide, second field is this number of bytes wide, and so on and so forth. So we were creating a fixed layout, record layout or schema for that data storage. So every time we open that file, we had to use this fixed record format to be able to work with that data. And that gets us into the definition, or the start of the definition of what we mean by structured data. So let's define structured data as data which has a fixed schema with no repeating subsets, and this can either be fixed length or variable length records. Now, I just covered fixed length, and if you think about it, once we started working with that, we started to see that there might be a slightly better way of working the data, and that's by creating variable length records. Now, to do so is you would have to have a special character to delimit the end of a field as well as the end of the record. Now, give you an example why that's more efficient. In fixed width records, if we have a field that's, let's say, for example, represents the last name, if I have fixed width, I have to set that width. And let's say we set it to 20 characters. Now, if you have a name that's over 20 characters, you truncate it. If your name is less than 20 characters, you pad it with spaces. Now, take my name, for example. My last name is 5 characters. So in my record, that's 15 characters of padding white space. Okay. Now, if we start looking at going with variable length records, I can take that savings of that 15 characters and I can use that as a field level delimiters because they're a single character wide. So if I did that across multiple fields, you start to see that I can on average shrink the records from the fixed width. So I'm saving more space. The more space I save means the more data I can store in that 250 megabyte space. But we start talking about fixed width and variable width records. What about this thing about subsets? Okay, so let's take a look at a practical example. We take a look at an invoice. Now, everybody knows invoices. We get bills all the time. So when we go to store an invoice, what we have is basically a master detail relationship. That is, the master record stores all that header information, you know, the invoice ID, the invoice date, bill date, ship date, the customer ID, customer name, customer address, shipping address, billing address, because they all be different or the same. We have other contact information all in the header. Then in the center, we have the actual inventory or invoice or line item detail of what was actually sent and shipped that they ordered. So you have your SKU, You have your product description, you have your line item quantity, the unit price, and then the line total price. And depending on what they ordered and how many items they ordered, you would have one-to-many detailed records. And of course, at the end of the invoice, you would print out your subtotal, your tax, your terms, and everything, and shipping, all those other additional expenses in the total. Now that tail is part of the main master record. So in reality, you have master record, then the detail, where you have one record to one or more detail items. Now, in fixed width records, I would store them in separate files. Now, if we think about it, in a simple relational database, what we've done is we created a master detail relationship. Okay, so that's an overly simple relational database example. Clearly, we would break the data down into more tables, and each table, again, would be fixed in terms of the fields, the order, and size of the record. Now, that's a relational model. Around the same time, we have what's known as a hierarchical model. And that is a hierarchical database. Think of a guy named Dick Pitt created Revelation. There's U2 Universe, and a few other ones that are out there. And really in here, what they did is you created a record. So you had a record view of your data, and we allowed a subset. So in other words, we had the master detail information, and embedded inside, we'd have one or more repeating subsets. And again, the master is fixed and the subset was fixed. Going forward, if you think about data exchange between customers or between companies, there's a thing called EDI, electronic data interchange. And again, here we had fixed width records to start with, and they had a set definition. And then we would say, okay, let's take multiple records. So we have a fixed width header record, and then we would, at the end of it, tell us how many sub-records we'd have of a specific type. And we would then read those in, and then we go on to the next record, and so on and so forth. That got later evolved into XML. Now, keep in mind that as we go forward, our data density and storage has increased, storage costs have dropped, so we're able to store more detail with the base information. So our fixed width had very little metadata. Our variable length records, again, had very little data. And now we start getting into doing a semi-structured, or we start having master detail relationships. We're adding more information. So when we get to XML, we can start seeing repeatable subsets. And then again, I'm getting ahead of myself. That's where we start getting into what we call semi-structured data. So looking at our definition of structured, we have it up on the screen here. Now let's talk about semi-structured. Semi-structured data is data that has a fixed schema, but may contain one or more repeating subsets that also have fixed schema. So going back to our invoice, remember how we set it up and said, okay, where I have my structured data, that invoice is broken down into two sets, the master and then the detail. When we go into our semi-structured data, thinking of XML and JSON records, we now have a fixed schema, but it may contain one or more repeating subsets. Now, when I mentioned JSON records, that's a little bit of a change, and there's a little bit of transition there, because JSON records themselves, an individual record, I can hand you in a self-defining, self-describing. So one data record, is one set. There's no standard definition. When we go back to XML, if you look at it, there are standard definitions for that record type. So that it's called, and there's also style sheets as well. And I'm not going to go into that. You can take a look and learn XML. Okay, so as you see, when we store our invoice in structured records, you have two sets, a master and a detail. And again, we talk about the relational models. each of those tables are structured, highly structured. When we look at a hierarchical database, it's semi-structured because we have the master and detail all within the same record. So you have two sets of fixed format, but combined into a single record. This is true of XML when we're looking at for transporting the data, where we describe the record and we have a set definition and a set layout where we have fields that may or may not exist. And then we have a subrecord which may or may not exist, and more fields and so on until we get to the end of the record. We start to look at JSON, and JSON does follow that. However, a JSON record by itself is standalone, that you don't necessarily need to define it outside of a single record. So you can have multiple JSON records that match. And this kind of starts to lead us into talking about unstructured data. All right, so before I get into talking about unstructured records, and I know that JSON records are a good segue, I want to take a step back and I want to talk about data types. So when we look at a primitive language like C, we have primitive data types where we have for integers, we have an int, which is an int, a short, and a long, three ways of representing numeric strings or numeric values. We have floats and doubles for floating point precision. We have a char for single character fields, and we have a string. Now, that's basically our primitive data types. And from these primitive data types, we can build more complex data types by using struct and typedef. And these are functions within the C language. To learn more about it, I suggest you pick up the old Kernighan and Ritchie C reference guide. Now let's talk about that for a second. Suppose I want to create a more advanced type. Let's say, for example, I'm doing geospatial data, so I need to talk about and define a point. Now, a point is a point in space. So we have three elements. We have an X, a Y, and a Z coordinate. Or we have lat, long, and altitude. That describes a point in 3D space. By itself, not much we can do with it. We define it, we have it. What makes it powerful is that we also have functions. So when we start talking about a geospatial coordinate, a point, what can we do with it? Well, if I have 2 points defining a bounding box, upper right and lower left, or upper right and lower left, depending how you're looking at it, I define a bounding box with those 2 points. Now I can do a function that says, is my given point inside or outside that bounding box? I could take a look at the distance between 2 points and see where they are, and so on and so forth. So you can start to see that the power comes from being able to define and build extended data types, as well as providing the functions around it. Now, if you're not a programmer, let's take a look at something different. Let's take a look at a relational database. So in a relational database, obviously we have numeric data types, we have alphanumeric strings, we have other things like decimals, but we have something like date. Now, a date's a very common little string, and it's day, day, month, month, year, 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 year. But by itself, we have built-in functions to make a value of it. So instead of just putting a date there or a timestamp there, we can take a look and say, okay, let's work with this date. Let's see what the day of the week is for that calendar date. Let's take a look and see the number of days between two dates, because not all months have the same number of days. So we have a little bit of calculation to be done. So as you can see, with more complex data types, we start to have functionality added to it by giving you functions and libraries to work with it. So that gives us value. It's not just the capture of data, but also the functions to work with that data. Now let's segue back into our complex data types in unstructured data. Now, unstructured data is a bit of a misnomer. By this, I mean that when you place data inside a container, that container adds structure to the data. Hence, all data has structure, or at least all persisted data has structure. So what do we mean by when we say unstructured? Well, let's take a look at some unstructured data types. Let's take a look at, for example, an image. So in that image, we have TIFF, GIF, and JPEG formats. So the container has that format, and inside there we have metadata to describe the image, and that sits inside the JPEG. But then we have this blob of information. It's basically a byte stream, and that byte stream will depend on the size of that byte stream will depend on the resolution of the image, and its contents will depend on what that data is captured. So we have to have functions again that allow us to do things like color correction, scaling and sizing of the image, and cropping of the image, and so on and so forth. So that's basically our container JPEG. We have some metadata that describes information and laid out where it is and the size of it. But then the actual image itself is a blob. It's just a byte stream, unstructured. So we take a look at video or audio. Same thing is that we have a container that has structure, and we have metadata that tells us where within that structure certain elements are, the size of those elements, and something about them. So the byte stream is still unstructured. And that's it. Now, as I said before, our data takes the shape of the container. So in our example of the invoice, I can store the invoice in two relational tables, which are highly structured. I can store it in an XML document, which is semi-structured, or in a hierarchical database, which is semi-structured. Or I can store it in a JSON object, which is semi-structured, but at the same time, because of its uniqueness, I can store that JSON record as an object. In fact, I can do that for the XML document as well. And when I store it as an object, it's basically being stored as a binary blob of a specific type. Hence, it's unstructured. So as you can see, the same data can be stored in all three different shaped containers or types of container, which means to work with that data, as long as you are given the appropriate libraries, you can work with it and it's straightforward. So there shouldn't be any complexity of dealing with it as an object in unstructured data, as a semi-structured data, or as structured data. And that's really it. So to recap, we define data as the observation of an event or object in spacetime. We define structured data as data that has a fixed schema with no repeating subsets that can be either fixed length or variable length records. We define semi-structured data as data that has fixed schema but may contain one or more repeatable subsets that are also fixed schemas. And then we have this catch-all of unstructured data. And we'll define that as data that has a fixed schema, but the data fields may contain data that may contain objects that are not of a predetermined size or shape, aka blobs. Now, using those three definitions, hopefully I've shown you how easy it is to put data that when we persist it into one of those sets of containers. These are the three definitions of types of containers that all data fits into. So if it doesn't fit into structured or semi-structured, it's definitely going to fit into our unstructured data. Now, if you think I missed something, please let me know in the comments below. If you liked what you saw, please give me a thumbs up. And if you think that you are going to be interested in future things, definitely please subscribe. And if you want to see a specific data topic talked about, by all means, let me know in the comments below or contact me on LinkedIn. Thank you and have a good day. And that's pretty much it. End of story. There's not going to be any funny bloopers or takeouts because basically I'm more comfortable behind the camera than in front of it. I have a face for radio and a voice for the silent movies.